Hi, everyone. Welcome to this new episode of Additive Talks. If you're joining us for the first time, make yourself comfortable. Additive Talks are simply a series of panels that focus on discussing the use of additive manufacturing technologies in a given industry. If you've been here before, thank you for listening to our insights into the world of AM. My name is Katie Sinze, Managing Editor at 3D Additive Media. And without further ado, I would like to give the floor to our experts so that they can introduce themselves as well as the company they represent. And I will start with Angeline.
Yes, and welcome everyone. My name is Angeline, and I'm based in Amsterdam. I have a background in mechanical engineering and has been with the company for 24 years. Today, I'm the additive manufacturing technology lead for the company. And what that means is that I am responsible for the strategy of how we use the technology. I set the maturation roadmap and manage the R&D funnel for the technology. Lastly, I'm also responsible for creating capability within the organization related to this technology and providing asset support from that standpoint. In short, I'm the ambassador for additive manufacturing within the company. Thank you.
Thank you very much, Angeline. And good evening, Lee. I know it's the evening on your side. Can you please introduce yourself as well as Woodside?
Good evening, morning, afternoon, wherever you're coming from. My name's Lee Dumas. I am in Perth at the moment, and I represent Woodside Energy, Australia's largest independent oil and gas operator. My role at Woodside is the technology platforms and integration lead, which means I'm responsible for scaling and deploying new technology at Woodside. That includes 3D printing or additive manufacturing, which we've been part of for quite some time. But I'm very excited to be here and with all of you. Thank you.
Thank you, Lee. It's a pleasure to have you. And last but not least, Sastri.
Thank you, Katie, for the opportunity to come to this panel and speak. Hello, all. My name is Shastri Kandukuri. I'm based in Oslo, Norway. I've been working here for last 18 years. A few years I was in Singapore. Earlier I was working in Belgium, Canada, and other places. So I'm a material specialist working in DNV, where DNV is an independent organization. We independently verify the product qualities between the suppliers and the end users. So we have the opportunity to be as a standards organization. Also, we write our standards and offer services. This is where we started almost 10, 12 years ago, writing our own standards, offering as a complementary stack for the oil and gas industry. Thank you.
Thank you very much, Sastri. It's a pleasure to have you. Well, today, if we are here today, it's because we need to discuss a very important topic: repair, retrofit, and reliability. Is additive manufacturing the key to extending asset life? Well, we have been following, a couple of companies for quite a while now, and some of them have been using AM, for a long time, and today they are going to share the experience, their lessons, on this specific topic. And my first question is for you, Lee. Woodside has often been quiet about its use of AM. Can you walk us through what's happening behind the scenes and how the company is using AM in particular?
Sure. So maybe we've been a little bit quiet. There's been a few things that we have released and discussed, but our journey goes back to probably 2016, where we really started through university partnerships exploring what was feasible and what was possible with additive manufacturing, primarily around alloy qualifications and understanding what was possible at the time. The big milestone for us probably came in 2021 when we deployed our first metal 3D printed part in offshore service. So that was a monoflange, a type of double block and bleed component, pressure retaining component that we're quite proud of. Since then, we've then scaled up that additive manufacturing essentially is an internal service to the business. So we've established a core team internal, which assesses requests and viability and feasibility of various types of AM applications. And then we partner with key vendors and OEMs, equipment manufacturers, to find the right solution for the right opportunities. As well as that, we've done a lot of work on the standards and specifications, both internal and external, to try and drive some of that. I'm sure we'll spend a little bit of time on that today. So at this point, we've probably deployed somewhere in the vicinity of 50 to 100 additively manufactured components, and we're scaling up every week, every month. So we're very proud of what we have achieved internally, and I'm hopefully to share some more of that today with all of you.
Hopefully. Good. Thanks. Well, in the case of Shell, Shell's name has long been associated with the digital inventory in the additive manufacturing industry. Angeline, how would you define supply chain resilience today compared to 2019?
Thanks for the question. So indeed, Shell started the journey using additive manufacturing about 12 years ago when the first metal 3D printer was brought in to help produce parts for experimental use. Now, when it comes to supply chain resilience, I would say we have pockets of successes. However, there's still a bigger journey to really scale it up and to be truly resilient from a supply chain standpoint. I'll talk about the few successes. The areas that I think we've done well. We have today a modest portfolio of additive manufactured parts that are deployed in the field, a modest portfolio of digital spares, as you call it. This contained within specific assets in very specific locations. The other aspect, which I think we've done well, is being able to support some of our assets in locations where we help to domesticate the use of additive manufacturing technology. And this includes the maturation of the knowledge of the technology for the local team. And that means that we have more knowledge as well as capacity in these local regions to make them accessible for on-demand manufacturing for the assets. The third one would be the growth of interest from original equipment manufacturers that I see they are coming to participate together with us to do developmental work for products that are novel in nature so that they are well adapted to be used in our industry. And for that, I hope to showcase, there are two projects that we've sent across for the international conference that are derived from direct collaboration with original equipment manufacturers this year. Now, I think supply chain resilience in itself is a big topic because, so it really covers what an organization as such is able to predict the changes that are coming, to adapt its processes, and then finally to recover from a supply chain disruption. I do think that digitalization is required as a way to underpin the transformation towards a more resilient supply chain. And as such, there are some foundations that we need to lay even as an industry. And I do think we are working towards that. The final thing I would say is that towards the supply chain resilience, I want to share that as an industry, I think we've made that concrete step towards working together to make it possible. And that comes through the work that you would hear more and more about, and hopefully also towards the end of the year, be part of reviewing some of the documents we'll be publishing under the International Oil and Gas Producer Association Group. So the first industry specification, as well as guidelines geared towards how the oil and gas and energy sector as a whole can use additive manufacturing more easily.
Thank you very much, Angeline. Well, let's try to hear Sastri now. Sastri, I know DNV plays a vital role in setting qualification standards. Have you observed any shifts in how companies are approaching qualification from one-off part testing to system-level strategies?
So thank you, Katie, again for this question. Yes, when we started this journey 12 years ago to set
Yeah,
up the standards, it took few years for us to assemble, they gather the interest from the operators.
yeah,
So slowly, that is how I visited, both Shell and also Woodside in 2017 area. So we have gathered several end users. So
yes.
we took 2 years of a joint industry project to release our first oil and gas standard
Mm-hmm.
uh, with their input and with their consent. So that time, the main question is more about just about crossing the feasibility to having some kind of a basic trust. So we started with two technologies,
Yes.
but quickly the interest in many other energy companies went, and the need for more qualification. Now qualification is actually more in, it's not simply for the basic trust, but really to deploy. So from innovation to the deployment,
Yeah.
in the next by 2023 we have seen a great shift. But initially we have focused, as I said, also your question refers, it was more about one part here, one part there.
Mm-hmm.
We have whatever the case studies they have taken, mostly these energy companies took obsolete parts, for example,
Yeah.
to replace one to one. But quickly they realized, even all these energy companies came out and said that more value is when we go to the system level qualification. And qualification should not be a burden, but
Yeah.
it promote. So we all together worked in the second phases of our joint industry projects and different other forums. Yes,
Mm-hmm.
definitely the standards evolved. What we brought a concept called part family qualification. So not only one qualification just limit to that. For example, sometimes qualification cost could appear to be like 3 to 4 times than the cost of a part if you are only going to one part qualification. But if you are trying to qualify that part and use that information for many similar parts
Mm-hmm.
that looks with similar, not only look alike, but have features like thicknesses, overhangings, and several other features technically. So you can actually utilize the previous qualification to and deem, decide that this new part that you need is qualified because other part gives you the confidence. So this way, this part family qualification as actually creating interest, and to reduce the cost of qualification, and not only for the cost but also the time needed to get the part in time. Okay, so because you can endlessly investigate a part to get the trust, but that would defeat the purpose. So there is an agreed framework
Yeah.
by all these energies companies, and this is what we are saying. What is the minimum that we need to do? And yes, definitely it is there. It is going towards system level, and um, I think that is getting standardized, as Angeline mentioned about IOGP now, is also trying to bring more adaptable specifications for these energy companies. I think this is going in a very right direction. Thank you.
Thank you very much, Sastri. Well, quick reminder for the audience. Please, if you have any questions, feel free to use the Q&A chat in front of your screen, and write your questions. At some point during the conversation, we will pause, and our experts will be able to answer them. So next questions for both Angeline and Lee. What do you consider the minimum requirements for demonstrating reliability in 3D printed parts intended for critical use in the oil and gas sectors / energy sector? And I will start with Lee, maybe.
Me.
Yes.
Okay. Yes, this is obviously a topic we spend a lot of time on. From my perspective, it's really a materials question. Really, the fundamental difference about AM are the material properties. From a design perspective, we know it can meet a lot of the geometrical requirements with processing and whatever we need. So really, it's a metallurgical, mechanical question of can the material properties meet the desired outcomes. And so from a component-specific standpoint, we obviously now have standards like API 20S and 20T, as well as DNV's STB 203, and that really helps us to do the kind of minimum set that we require. When we talk about critical service, though, we obviously need to do our typical failure mode analysis, risk assessments to understand what's likely to occur, and we need to do them. So I guess in short, we don't really have to reinvent the wheel necessarily. We just have to follow standard practices that we've either established recently or that we've been practicing good engineering practices in our industry for a very long time. So I think that's probably enough for me. I'm sure Angeline has a few more points.
Yes, I notice, of course, coming from you.
Of course, it's a materials question. I'm a materials engineer.
Yes, and from a mechanical engineering standpoint, I think what I would say complementary to what Lee has provided as an input is I try to, for the projects that we take on board, be very clear about the operating condition in which the part is required to perform. And then assessing what applicable standards as well as regulatory requirement would be on the critical component. That then gives us very clearly a premise for how to design and ensure the required inspection testing is done on the part. The inspection and testing has two components I see being very important. The first one is related to the additive manufacturing nature. As what Lee pointed out, material does have slightly different microstructure in the way that they are produced. So the international standard has also already designed or defined the required testing, minimum testing based on the criticality level. Over and above that, understanding the operating condition and the type of product that we are making for additive, we need to apply as well product-specific testing. And in combination, when knowing that these test results are met, we can have some confidence in the quality that's been produced in the parts before we install.
Could I add one final point? Sorry, just something to me as Angeline was talking. But one key thing that we've observed is in terms of a manufacturing maturity as an industry. One thing that the energy sector is very specific on is around quite extensive documentation and traceability. And so we've had quite a journey in bringing up our maybe less experienced manufacturers to a level that we expect the documentation and traceability to be at, where maybe some of our more, so that's probably just a note for some of the audience if they live in that world. That's incredibly important to our sector.
Thank you, Lee. And Angeline mentioned standards, and one question for you, Sastry, is how are standards, like for instance, DNV STB 203, how are they helping the energy sector move from trial AM applications to trusted, repeatable deployment across asset life cycles? So I know there are a couple of standards from DNV, but also API, if I'm not mistaken. I don't remember the exact, code, but if you understand the questions, please go ahead.
So thank you. This is a great question to connect, to the previous question. As Lee mentioned about, the material uncertainties, so and also as Angeline said that about, how do you get a product that have no material uncertainties? and also that can be tested to be suitable to a functional application, like whether a pressure equipment or a rotating equipment or something. So this is what we call in generally process structure and a property correlation method. So this is our standards have inbuilt whether it is a DNV or also the API 20T, etc. 20T and 20S, etc. So these standards we have inbuilt the how to test your specimens in a correct locations where that could be a weaker spots, to understand and to tackle the AM material specific uncertainties. So and then so most of these standards, if you are successful with this basic process qualification and part qualification, now you can trust a kind of a locked process. And then now when you produce repeatably the more parts using that as a base. So this is where your question also about how it is moving from a how to a full scale deployment or wider a repeatable deployment. Yeah, once you get that confidence about them, as also Lee mentioned about the manufacturers,
Yes.
no two manufacturers ever can be same, but you can always benchmark them to a level. If all are above that, that is what DNV is also doing, something called qualification of manufacturer. So through this setup, yes, these when manufacturers and their process and parts are qualified,
Yeah.
using the framework given, the qualification framework given in these standards, that is actually bringing not only the required confidence for one part, but when you repeatedly go for parts, because the main difference between the conventional processes and the AM is, many conventional parts you fix your process and everything set up one time and you produce millions of parts continuously. So but oppositely, in IAM, you produce millions of parts only once. So you have to change so many setup files, machines, powders. This is where you need to address. So these standards are addressing that, even though you are producing one part, one now and after 1 month, after 1 year, still these standards are giving that good framework. You can get as if these are at par with the conventional quality, and are even often better quality. So yes, definitely. But another point I wanted to add, there are several standards. DNV and the API standards are on the top of the application area, whereas there are many standards like ISO, EN, and ASTM standards. They are also very much in the bigger framework of standards, and we are all interlinking these standards, so that these become interoperable, or you can use any set of standards in a combination, one for qualification, one for part, and one for other production. But yeah, so there are some overlaps on these standards, but I think the most of the standards are now filling that piece of the puzzle that is missing in the broader concept. So yes, definitely these are helping, and I think now we have that basic groundwork, and now the time is going to tell us how fast we move. Thank you.
Thank you very much, Sestri. Angeline, how does, if we want to talk about practical applications, for instance, how does Shell evaluate whether a part is a good candidate for additive manufacturing versus traditional sourcing or repair?
So I think for us, at least today, when we are approached with a part to manufacture using additive manufacturing, there are a few factors that we immediately look into. Things like the size, the material, the operating condition, the geometry complexity of the parts, as well as the quantity required. Now, the quantity required, of course, plays a role over a defined period of horizon, because additive on a part-by-part basis, depending on the material can still be expensive. And we hope that we can work towards changing that. And that could come with either defined product specification for AM product, which simplifies the way to make them.
Yeah.
It comes with a scaling up of technology, being able to make more parts at the higher speed, meaning better utilization of existing fleet of machines that are available. So cost can come down. But one thing that we do have to evaluate as a company, because we are ultimately end users of the technology, we do
Exactly.
use case a cost versus benefit ratio before deciding the optimal remanufacturing technology to go forward with for particularly obsolete parts requirement.
Yeah.
These are the considerations for us.
Okay, good. I'm going to ask one question to Lee, and then maybe we will take a couple of minutes to answer, the list of questions in the Q&A chat. Otherwise, we won't have time to go through them.
There's a lot.
Yeah. There's a lot. So, one question for you, Lee, maybe before we move to the Q&A chat is, what are the technical or maybe logistical challenges, you often face when deploying AM technologies for offshore or remote energy sites, if they are? If you can share a couple of them with us.
There are none. It's very straightforward. No, I'm joking, of course. Look, there's obviously some fairly unique environments that we operate in, but we're not alone. Marine shares similar scenarios, but it's also a fairly large sector. It's as difficult as we make it. I think the primary consideration is really around integration. So how well can we integrate AM into our current supply chains? Okay. And so that's not just a one-off kind of insert AM here. It's really looking at the whole supply chain up and down, and how do we find the most suitable place to use AM all the way. And so I think when we do that, we can overcome many of the logistical challenges, a lot of the technical challenges.
Yeah.
Deploying AM offshore is well, we've spoken probably enough about the standards and the processes and things like this, because that obviously plays an important role. But once we have confidence in the part, we know how to insert it into our supply chain. Really, once we get it offshore, the hope is that we can treat it just like any other part. Yeah.
Okay. Thanks, Lee. Let's try to move to the Q&A chat before we continue our conversation, the main one.
Yes, we did overlook about the AM technologies. We probably should have mentioned that. Hey, Angeline.
Yeah. But maybe question number one from Steve: which AM technologies or approaches have proven most effective for repairing or maintaining equipment in oil and gas? I think Sastry has the theory. Angeline and Lee, you have the practice. So in theory, Sastry, what do you recommend? I mean, what do you see as the most important AM technologies? And then I'll give the floor to Angeline.
So thank you. Definitely, we have the theory. So, for example, in our standards, both in DNV and B203 and API 20S, so we have covered 5 major technologies. One is missing, but that it would be coming soon. So we have broadly powder-based technologies. They are not very much suitable for repair of the components, whereas we have what we call directed energy deposition technologies, like LMD or wire arc additive manufacturing, similar to welding. And also, other third technology I was trying to mention was cold spray technology. So this what we call a laser-based, powder-based DED, and also wire-based DED, that is warm, and cold spray technology. These are mainly applicable for the repair. So yeah, we talk more, but I hand over to Angeline and Lee. Yes.
Angeline, do you confirm or not?
Well, I concur that there are a lot more technologies available. And from an experience standpoint, and I would say experience and acceptability within the company, we find ourselves gravitating towards Repair, when I talk about repair, I talk about repairing a particular component out of a wider assembly. So that is a full manufacturing of a component. We have found ourselves using predominantly powder bed fusion as well as a wire arc additive manufacturing. For those are quite established, well understood, and there is sufficient data at this point for us to make sound decision around the design as well as testing processes.
Thanks, Angeline. I know Woodside has used gold spray in the past, but I'm not sure if it's relevant for, repairing or maintaining equipment.
We didn't classify it as AM in the instance that we deployed it. It was really for a coating repair. It was extremely effective, but yeah, for AM, not so much. Robotic welding is another one that can kind of sit on the boundary as well, where we can perform in-situ welding. We kind of put those in their own bucket. For new parts, I concur with Angeline. Powder DET is also an option. But again, I would say that if we're repairing parts, the use of, weld overlay or hard facing or resurfacing components is not all that new. Again, we've been doing it for quite some time. And so again, there's very well established processes for us to do this.
Okay, thanks.
Agree.
Let's try to be a bit brief when answering. Otherwise, we won't be able to go through the list of questions.
Quick fire.
Yeah. So question number 2. Question number 2 is from Bernard. I think it's already down at the bottom, if I'm not mistaken. I'm looking for it. Bernard Van Riesen, founder and CEO of Spelly. How do you look at predictive maintenance, especially estimating the parts lifetime and replace before they break? Ooh.
That's a tough one. We do this, but it's not certainly in the additive manufacturing, or exclusively, at least, in the additive manufacturing remit. Kind of conducting these sorts of analysis is a world unto itself, which we do look at, but not just in the AM space.
Okay.
So I can share a little bit in that space as well. So predictive maintenance, particularly monitoring of larger equipment as such, is of course already very widely used. But being able to, from the predictive maintenance, predict the exact component that will fail, and therefore the requirement of a specific part is where there is more effort needed. Quite often, the placement of the sensor, the sensitivity of the equipment, and the data that you get needs to be digested in order to infer the maintenance strategy as such. And this is where I think I certainly see high potential and interest to do so, but it needs to be thought out in a wider context of critical data across the maintenance to supply chain processes, the integration and interoperability of the various systems that we use today in an asset to be able to execute it seamlessly. And I think it goes back to a point earlier we were talking about. It is about the process. What is the process that we are able to implement in the asset, embedded in the day-to-day processes today? What is the how are people trained to execute the process and understand that the requirements accordingly, as well as finally the data and the integration of the systems to make it work. So there's certainly a lot of interest, I think, in this area.
And I think it's quite linked to, this question is quite linked to question number 3 from Viraj Patil. As we are discussing about the repair and retrofitment, may I know which AM process will be preferred? This one, we already discussed this. This question. But then he said the mechanical properties of deposited material will be the same. I'm not sure if that question needs to be reframed.
But no, I can answer that. Also connecting to the next question number 7 from Victor. Generally, now we need to say something about, the difference between certifying a component, a full-fledged component, versus certifying a repaired part or a repaired process or a repaired component. generally there is no certificate issued when you do a repair. Okay, so you only have for example, if we take a comparison like weld repairs, you have a approved welding procedure specification, and then as long as you use the right person, qualified person, and you apply it with some kind of a qualified or a approved repair procedure, you are okay. You don't issue a certificate like you issue to a new part or something. So also, as we said earlier, the parts coming from a qualified manufacturer, but do we need the manufacturer? Because there is no manufacturer here. When you do repair, generally, unless you could also actually take some worn out components to a workshop where you can repair. So there you get a manufacturer. So that is one scenario. Another scenario is you are doing repair in the field. Okay, so for these two scenarios, for example, the first scenarios, we could use the qualified manufacturers. That is where you get this question to Viras about the mechanical properties of deposited material. So as long as the manufacturer is following the qualified process parameters, as long as he is within that window, and you have tested widely that, and with a limited testing, you could trust that. That is the way you do. So coming to the Victor's thing, yes, for the field.
I think that's question number 7. Is it linked, or Sastry?
Yeah, it is linked because he's asking how do we qualify, or how do we, what is the difference? So when you go to the field repair, generally you need to have a qualified repair procedure. And apply it. Same for like in welding, you could also qualify it for an additive manufacturing process with some kind of a field qualification that works for general, and you need to do small adjustment case by case. So that is how this works. You don't issue a certificate at the end for the field repair, but you could issue a certificate if you are repairing it. You can issue, it's not a full new manufacturing certificate, but a repair certificate could be issued in a workshop. So this is how the moral is here, or the message here is that you need to have a qualified process at some point of earlier before you do repair. You should not jump in and repair.
Thank you very much, Sastry. Moving forward to question number 4 from Sagar. Can DFAM reduce the requirements of additive manufacturing for spare parts?
I'm not sure what you mean by reduce the requirements.
I think from a material standpoint, yes, it can. Design for additive manufacturing. We've seen quite typically when we consider a need for a part to replace a part that is damaged, and we leverage topology optimization, then the material reduction is significant. So ranging from 20% to upwards of more than 50% in material requirement. So that is indeed, if we are able to deploy it at scale, quite a big improvement. However, I think it opens up also another dilemma, because conventionally, a lot of product specification that we know of are written for traditional manufacturing. So I do see a bigger piece of work that is needed, whereby engineers, particularly skilled young design engineers, getting involved in a bigger way to help provide the development of new product specification, product code that actually leverages additive manufacturing, because topology optimization creates quite different geometry and shapes, which requires different codes to be written in a way that will allow it to be acceptable for site deployment.
Good. Lee, do you want to add something? Or that's fine.
I was just going to say that I think there are benefits to be had, and in fact, I think most of the good business cases exist when DFAM is utilized. But in some instances, it actually increases the requirements because we need to go through additional qualification steps because of the redesign. There's additional stuff, but you have to weigh that trade-off. if the benefit is there, then it is worth doing that extra work.
Okay, good. Thanks. I think I'm missing question number 5 in the chat. So I will move to question number 6 from Jacques. There are qualification standards for processes and applications. If we could only afford one, what should we prioritize? I think that's a question for Sastry.
He's a bit biased, though, I'm afraid.
Yeah.
Yeah, but here it is, they're not asking whether it's the we have some, but yes, qualifications. Yeah, I mean, of course, we could go for maybe I take it a little bit neutral. But we have some kind of interoperability between these standards. So, but the question is, one should not think qualification is a burden. It actually adds the value and give you more business. So you start somewhere X, Y, wherever, and then you will realize that you want this actually helps you to prove your quality, and you would certainly go for the more and more the qualifications, because definitely the value comes more later than you realize, because in the beginning everybody thinks this is a formality and burden. Yeah.
I like how you answer the question without answering the question. Like, you didn't say which one we should prioritize. You just say, well, don't take it as a burden. Go for all of them. Okay. Question number 8. I feel like, well, Sastry, you already responded to question number 7 from Victor. So let's move to question number 8 from Viraj Patil. Particularly in the oil and gas industry, we have existing fuel oils and which are not available in the EM. In the powder or spool, in that particular application, how that part can be repaired. I'm not sure I understand that question.
I do.
Okay, Lee.
Very well. Yes. Actually, one of our general philosophies was to try and reduce the number of alloys we would qualify for AM, because of the burden that is required to really understand the material properties. So what we looked to do was to single out a few of our high use that could be used across many different applications.
Yes.
So what we've typically done is gone to up spec is what the shorthand for it is, but it's typically using higher grades of alloys to suit larger number of opportunities. And so, of course, there is a slight increase potentially in the price, but the benefits I've just kind of listed out of not having to repeat qualifications extensively is absolutely worth it. And so depending on the technology, of course, if we're talking LPBF, then up-speccing is a relatively cheap exercise.
Yes.
If we're talking about YADED or WAM, then this might not necessarily be the case. But I would also say about YADED is that if you can weld it, then you can obviously manufacture it. And there are a huge plethora of welding wires that are widely used for quite some time as well. So, yeah, hopefully that answers the question.
Thanks, Lee. Angeline, do you want to add something? Yeah?
Yes, and this may be a bit of going around it as well. As I talked about, we always evaluate the benefit versus cost ratio in the evaluation of how to proceed with the project and the selection of the remanufacturing or repair techniques. So one of the, in a number of instances, and this would probably also address question number 9, is actually where we have a rather large unit with many components in duplicates. And the quantity needed was well over the hundreds. In this case, what we then did is to actually consider using additive manufacturing for the creation of mold with final casting as a way to still produce the part. So that gave us freedom, a lot more freedom with the material choices. And for the large quantity we were looking at was also cost effective. So this could be a situation in which there are, I would say that's the agility of additive manufacturing. You can print in many different materials. You could also consider the manufacturing of the mold as such when the quantity increases. So providing a lot more versatility for us.
Thank you very much, Angeline. Question number 10, if I'm not mistaken. What are the main applications of DED metal-EM technologies for on-site repair in the energy sector? That's from Johan Carlos. Question number 10. Lee?
Yeah, I thought you'd be looking at me to answer this one. So there's obviously certain. I mean, there's if you have a look online, there's a number of different applications that have been proposed to be used. I would think that there's been some great wins publicly available by some other operators and how they've used it. I'm thinking of instances where it's been used for very large rotating equipment, so propellers, impellers, things like that. Also large kind of tubulars, so think like bushings, potentially even temporary fittings, connector pieces, things like this. Obviously cases where the geometry is relatively simple, but the parts are complex. Now, the benefit of oil and gas is we tend to have very large round things all over our asset. And so there's potentially ways that can be used. I've also know examples where potentially clamps and things like that have been used as well. So there are a number of opportunities out there. It's really just making sure you can find the right one for the right cost, for the right qualifications.
Thank you.
I can add like valves, drilling components, like they're worn-out components, where components like pump, impellers, etc. Again, when we talk about this, we are talking about having a proximity, on site, because this is not something like welding. You go there, but you have a facility for the repair in the proximity of operations, where you could, repair heat exchanger parts, pump parts, and other flanges, some corroded pipe components, etc. also could be possible, in addition to what Lee said.
Thank you very much, Sestri. And I think question number 11 is for Angeline. In laser powder bed fusion, what will be the bed size max or covered most of the parts? In wire additive, what will be the max size required in XYZ? Material-wise, which is the mostly used alloy? I think you mentioned that at Shell, you've used wire arc and LPBF, right, Angeline?
Yes, and I can't see the question 11, but
question 11 from Franklin. That's it. Can't you see it?
No. So the question was the right size. So how do I select a size of a printer that will meet most of the needs of the additive manufacturing requirement for a potential energy customer? Can I summarize it that way? It's a difficult one because we've had that question a couple of times, and also for locations where they are considering to domesticate the technology themselves or working with partners. We do find that today, as it stands, you need to first understand what type of parts you will be making before you select the type of technology.
Correct.
You need to understand the demand profile and who your potential customer, what the kind of profile they're looking for. And that's very important, because if you have a demand from a particular location that focuses on rotating equipment parts, a diffuser, impellers as such, which has a very need for high tolerances, as well as complex geometry, you may be limited to technologies like powder bed fusion just to have the agility to do them. And if you look at the size selection, you should also consider what are the typical demand profile for the customer, the type of equipments that they have before you make an investment decision on the printer, typically what we see is that very quickly for energy, the sizes does matter.
Yes.
They do get quite large. Here in our own facility in Amsterdam, we do have a large format metal printer that
Yes.
takes care of a substantial part. Even then, we do need to also partner up with a third-party service provider for the larger size component. So it is difficult to pinpoint a size. I think we're limited by the development of the large format printers today. They do come with also additional considerations as well with quality management. Typically, larger format 3D printers are equipped with more lasers on them. And these lasers also means there are more overlap zones, which needs to be managed in terms of how to then produce the quality that is needed. So it comes with certain trade-off, but best to start with understanding the demand profile of your potential customer before taking the decision with the type of printers and selecting the qualification of that printer for the type of materials that you need to produce with.
Thanks, Angeline. 9 minutes left, 6 questions left. Question number 12. Question number 12, how do you source the required materials from different global locations and keep as a buffer for tackling the repair/retrofit and when needed from the field operational standpoint? Ooh, that's a tough question.
I would say we typically don't do this. We rely on our vendors to do this. So we work closely with them to ensure that they understand our expectations, our upcoming demand, as Angeline was just mentioning, so that they can manage this. Yeah.
Okay.
I'm giving short answers now, Katie.
Thank you. I needed a short answer, indeed. Angeline, I think that's the same for you, right?
Yes, we understand first we by now have an idea year on year how many requests are coming through our desk. And that gives us an idea of the type of material powder requirement. But what I would say is building supply chain resilience is similarly also required for a facility such as an AM facility. Therefore, having agility of multiple powder sourcing locations would help.
Yes.
And additionally, adaptability, working locally with the option of recycling and regeneration of the metal feedstock would be very helpful. This applies even for polymer feedstock.
Yeah. Well, supply chain resilience in itself, it's a really, it's a whole chapter. It's a different topic that requires, another 15 minutes if we really want to tackle it, step by step and angle by angle. So I think we'll just have another, session on this specific topic. Question number 13 from Yuan. Could the panelist share a successful use case for the repair of components using metal AM? In particular, DED processes. Ooh.
For rotating equipment, I think is right up there. Personally, I think that's the one that makes the most sense at this point.
I can mention one from Kongsberg. This is a public one, publicly available from one of our GIP. Where you have a forging and there is a crank pin, so you have to otherwise machine, take a very large forging and you have to machine for a small, like a 2-inch diameter crank pin that is only 2-inch height. Yeah, so that pin is important to be there, and once they are getting, losing that pin, worn out or whatever, rather than machining from a new forging that takes 6 months to get, they have used wire arc additive manufacturing to quickly build in few hours to this pin and machine it. That's it. So you have saved 6 months, and also you have saved a lot of machining, and it's a high value. The component is just back in few hours into service. So we have several examples, but again, these are published one to many times. I think we have short of time now to
Yes. Well, Sastri, you can always share them with me or after the call by email. And then when we will publish the recording of the sessions, I will make sure to add them, in the article for everyone to see. Question number 14. As we are discussing about DED, warm and cold spray, there are still limitations in terms of build volume. And also, what if the retro repair has to do at site location? What is your view on how we can solve this issue?
I mean, this is a technological question, and this is certainly not something that we task ourselves with doing. If I could speak for Angelina and Sastri here, this is where we look to the market to produce solutions. The one thing I would say is that we do use a lot of big things. And so if viable, reliable solutions are available, we would certainly be looking at them to address our needs.
Yes.
Yeah, warm actually don't have a much build limitation, and also when you use cold spray in a different way, that's also don't have a limitation. But again, as Lee said, this is a technological question, and I think these kind of questions that are also important for us to give to the industry, the technology industry, to see that somebody is looking for these things as a limitation. Yeah.
Thanks. Question number 15 from Ante Era, right at the bottom of the Q&A page. Have there been any AM retrofits or repairs that underperformed in the field, and what were the root causes? I like this question. Thank you very much.
That's a great question.
Yes.
Specifics would be difficult to discuss, but I would say that if we go to a root cause, it's just not understanding the material behavior well enough for that application and not doing enough groundwork to ensure that it's fit for purpose. Because we sometimes make some assumptions about the material properties, and they might turn out to be wrong if the use case is complex. There was a question about alloys, and so I feel like I should quickly answer that. I think for the most part, we're using typical alloys, right? We're talking 316, Inconel 625, 718, aluminium, nothing, hopefully nothing as a big shock to anyone. But yeah.
I think for us, at least a few instances where the additive repair or the digitization of the part has to be done on site. It's because the site realizes that was the absolute last part and it's in operation, and it is critical, therefore, to already prepare it. We can't go into the details of the root causes, but this is where situation doesn't permit us to do it, in taking it out of service and putting it in a location such as a laboratory or facility to do the work. So we do travel down to where the part is and to try to gather accurately and efficiently the information needed for the repair.
Yeah, thanks, Angeline. And 2 more questions, and then we will close up. I'm really sorry, but if you have any other questions, please feel free to share them. And I will share them with the panelists, and we will take some time to write a proper article on the topic. Frank, question number 16, that's for you, Sastri. In the discussion, we mentioned the API standards for AM in the oil and gas sector. How do they differ from the ASTM-based standards for powder bed fusion technologies, which is developed already for aerospace and space applications? Yeah, Lee, you want to go ahead?
No. I was just going to say Sastri has to answer this in 1 minute. It should be interesting.
Yes, because ASTM, you take it like a T-shaped, where ASTM standards are quite broader and application neutral, whereas
Mhm.
the DNV standard and API standards, these are very sector specific and very deep into the subject. So that is why, but they are interlinked and use each other's strength. Whereas the ASTM is more about materials and testing, how to do testing, etc. But whereas the API, etc., gives you a risk-based testing. So because that component is in its mind, whereas ASTM is for any type of it. And again, when you see for the aerospace, the risks in aerospace are different compared to oil and gas. So again, so that's what you cannot use application standard from aerospace to oil and gas and vice versa. But ASTM is in the baseline, whereas these application standards are addressing the risks. Yeah.
I think simply put, the type of failure mechanism for
Yes.
components that are in our industry exposed to the environment
Yes.
products are quite different, and there are failure mechanism triggered from a different environment, which
Mhm.
are not specific enough in the way it's originally created in the earlier documents, which we are trying to supplement.
Thank you. Lee, do you have one word that you would like to share before we close up?
In general,
Yeah, in general, maybe. Yeah.
look, I think you put me on the spot there. I think in general, I would say that the key to success for us, for our industry, and really for any industry, is really about identifying those high value use cases. We saw a lot of the questions were focused on them. And I think there's more work for us as an industry, both the operators, maybe less so the standards body, sorry, Sastry, and the OEMs and the vendors to find these AM use cases and opportunities. And we need to be a little bit smarter, a little bit more creative about how we utilize it and integrate it into our assemblies and components that we procure. So I think that would be my main message for the audience.
Thank you.
Thank you.
Thank you very much. Well, time's up. I know this is so tough. Well, it's not supposed to be a game, but well, that was a tough conversation and a tough session where we had to answer a lot of questions, and there are still questions that remain unanswered. I'm really sorry about it, but be assured that I will share these questions with the experts and by email, and I will share their answers in the recording sessions that will be published on our online media. Thank you very much for staying with us during this entire session. Thank you, Angeline. Thank you, Lee. And thank you so much, Sastry, for joining this episode of Additive Talks. Really, I enjoyed the session, and I hope you do. And I hope we will have a follow-up conversation in the upcoming months or next year to see how far the industry, has progressed, has evolved on this topic. So, yeah. Well, stay tuned for the next panel that will be announced soon. And well, stay tuned and stay safe wherever you are in the world. Thank you so much again.
Thank you, Katie, and thanks for the good audience.
Yes.